Today I'm going to help you solve problems using the reciprocal rule. So as we continue working on parallel circuits, sometimes I'm going to give you a problem and I'm going to make sure that you realize that there's no voltage provided. And when you don't have this information here, and you don't have a way in which you can go about solving or finding current, you're going to have to use the reciprocal rule. And the reciprocal rule allows us to take the existing branches, what we see, and make sense of calculating the total resistance. So here's what we have. Here's the language. So for finding total resistance, it's what we're looking for. So 1 over the total resistance is going to equal 1 over the total resistance in branch 1, plus the total resistance in branch 2, plus the total resistance in branch 3, plus 1 over the total resistance of branch 4 in this case. So we need to make sure we can set this up correctly. And we're looking at fractions first. So first off, we'll start with 1 over 3. So I've got 3 ohms total for branch 1. I'm going to add 1 over the total resistance for branch, right? Resistance here is 1 over 8 ohms. Here, if I add 3 and 4 and 5, I get 1 over 12. And 2 plus 4 plus 4 plus 2 is 1 over 12. And so here I've got my fractions all set out. But I'm not done, because now I need to find what's called a common denominator, right? So I need to find my common denominator. So 3, 8, and 12 all go into 72 very, very nicely, right, as whole numbers. So that's my common denominator. So I can write it out. My next line here is going to be, so 1/3 of 72 is 24. 72, that's the same as 1/3. 1/8 of 72 is going to be 9 over 72. Plus 1/12 of 72 works out nicely. I get 6 over 72, and 1/12 will be the same here, so 6/72. So what's going to happen here is now over 72, I'm going to add all these together. So I get 24 plus 9 is 33, plus 6 is 39, plus 6 is 45. So I have a fraction here, 45 over 72. But remember, this is 1 over the resistance total. So I need to obey the rule of my reciprocal rule. So you're going to find that the resistance total is going to equal 72 over 45, which comes out to be 1.6 ohms of total resistance. And so let's apply that. We're going to, and you can always pause and go back and take a look at that. Let's do this again, and I'm going to give you a little bit of different information here. And in this case, I will make sure that we are able to solve with more information. So here I'm going to provide you. So instead of doing the resistance rule to start, I'm going to provide you a value of voltage. You having a voltage and resistors along each branch is going to help. This is just a much slower, it's just a different process. You don't have to use a reciprocal rule for this, but the reciprocal rule I always feel like is a good one to kind of safety net, kind of go back and check to see what you did or didn't do. So here goes. So the first thing you're going to do here is that I'm asking you need to make sure you understand the problem. You have a 9-volt battery here. This is what is pushing current. I have one branch here. Here's a branch. Here's a second branch. Here's a third branch. And here's a fourth branch. There are 4 branches here. So we now need to solve for the current along each branch. So I'm going to do this. And don't overthink this. We've done this a million times so far. But my current, right? I know that Ohm's law tells me that current or voltage is current times resistance. I'm isolating I. Current is going to be solved by the total voltage along each branch divided by the resistance. So I'm going to solve for you. I'm going to make sure I calculate my current first. So along branch 1, 9 volts, right? I get 9 volts along branch 1. 9 volts divided by 4 ohms is going to be 2.25 amps of current along this branch here. Boom. 9 volts divided by 6 ohms, 2 ohms plus 4 ohms. So voltage of 9 volts divided by 6 ohms. It's going to be 1.5 amps of current along branch 2. Boom. Branch 3 is going to be the same. 9 volts, right? 9 volts. Keep coming back to your 9 volt divided by 6 ohms. Is once again 1.5 amps of current. And then lastly, branch 4 is going to be 9 volts, right? Everything's 9 volts divided by, just add up your total equivalent resistance here, divided by 9 ohms, works out very nicely, 1 amp of current. So in order to find my total current here, I go back and I add together my individual branch currents. So I add all 4 of these together. 2.25 plus 1.5 plus 1.5 plus 1. So if I look at this, I've got 1.5, 1.53 plus 1 is 4. I get 6.25 amps of total current. But notice, if I have 6.25 amps of current leaving, I also have 6.25 amps returning. Notice, 6.25 amps leaving here. If 2.25 get diverted this way, I take 6.25 minus 2.25, and you'll find that between branches 1 and 2, I have 4 amps of current here. It's the remaining. This 4 amps has to be the sum total of my remaining branches. 1.5. 1.5 is 3 plus 1 is 4. And notice 4 amps here. 1.5 amps get rerouted through branch 2. And I have 2.5 amps here. Boom. And 2.5 minus 1.5 gives me my 1 amp remaining. Notice it's going to travel around here. It's going to pick up this 1.5. So notice here, cutting back this way, is 2.5 amps. It's going to pick up the 1.5 here. And this is going to be 4 amps. And you'll notice that this should be the same as this, where this should be the same as this. And this is 1 amp everywhere in here. So my total current we've decided, or we've determined, is 6.25 amps. Now my resistance. Let's do this. Resistance value here. Resistance is going to be my voltage divided by my total current, right? Total voltage divided by total current. Voltage is 9 volts divided by my current of 6.25 amps. And you'll find here, when you calculate this, this is going to result in 1.4 ohms of total resistance, right? If you have your current and you have your voltage, you can just solve using Ohm's law, right? My resistance here is going to equal my voltage divided by my current. And that's what we solved. However, I'm going to show you how to do this, and we can confirm that 1.4 ohms. We didn't need this voltage to solve this, and I can use my resistance rule. Now I'm going to go a little bit quicker here. I'm going to jump right into my numbers. Like, I'm not going to draw all of these out for you. I'm going to kind of jump into it. We can shorten it. Just practice allows you to do that. So here I know that I've got, so I'll try to work just in this box right here. Boom. So I've isolated that. Let's move this over. There we go. So here I have 4 ohms total. So my 1 over resistance total is going to equal, so 1/4 plus 1/6 plus 1/6 plus 1/9. And that's key. So I have my fraction set up. So now my common denominator is going to be out of 36. So I'm solving for, what are these fractions x out of 36? So where I have 9/36, here I have plus 6/36 plus 6/36 plus 4/36. And I come up with, by adding these all together, I get 25/36. So my value here, afterwards, after all this is said and done, is 25/36. And that is what's equal to 1 over my resistance total. So I have to invert both of them. Boom and boom. And as a result of this, you will find that my resistance total is going to equal 36 over 25. And some very quick, some math here, you will find that 36 divided by 25 equals 1.4 ohms of total resistance. And these two values here should be equal. I hope that was useful.